Good morning. Welcome to today's lesson. We are going to tackle the subject of chemistry, specifically on one of the long processes that normally normal tested in paper two. Today I want us to learn about the Solvay process. The Solvay process. And this process basically is being used to process or to produce ammonia in industries. So this one is a large scale production, or it is used to produce ammonia on large scale basis. So this is large scale production of ammonia for use in industries. There are several things that a student must be aware of. And, as far as the process is concerned, the students should be able to know the raw materials for the process, the raw materials for that process, and another one are the basic or the main reactions involved, the main chemical reactions involved. Also, it is very important for someone to be conversant with the materials recycled or the recycled materials. The recycled materials. And lastly, the byproducts. The byproducts for the reaction. And above all is the overall reaction for the whole equation. The overall equation. And the impact of the environment, the environmental impact of the process on the environment. And lastly, but not least, the students should be aware of the reasons for recycling. The reasons for recycling of the raw materials, of the materials that are being recycled, as we are going to encounter in the process of the solving production of ammonia. Now, we can just go straight to the production of the ammonia itself, and in this case, we are going to look at the first thing we have seen, that is the raw materials for the production of ammonia. So, what are the raw materials for the production of the ammonia, or the production, or in the solving process? What are the raw materials? Now, the raw materials here are mainly one is what we call brine, and brine is simply concentrated sodium chloride. Concentrated sodium chloride is what we normally call as brine. This is what we call brine. Another raw material is water. Water is also being used as a raw material in the production or in the solving process. And another one is ammonia gas. Ammonia gas. As you are going to see the sources of ammonia from different sources. And lastly, we have the carbon dioxide gas. Carbon dioxide gas. These are the main raw materials when the process is being initiated, or the establishment of the process. Those are the main raw materials. Now, how are they combined so that you can get the final products? Brine, which is usually concentrated sodium chloride, is reacted with water and ammonia at different temperatures. And now there are the first things that are being reacted, or the first reactants that are being reacted. One, we react carbon dioxide with ammonia and water. That is the main reaction, the first reaction that normally takes place in the upper part of the chain. And now the product for the first reaction gives us what we call to give us sodium. Remember that we are reacting ammonia, water, and carbon dioxide, and then the product of the reaction is being reacted with brine. So remember, we are also adding ammonia here. We are adding ammonia so that we can have ammonium hydrogen carbonate, which some of the books call it ammonium bicarbonate, but the most what I'm trying to note is the equation for the reaction. Now this one is a main reaction. All the main products that have been formed in step 1. Remember this is step 1, a reaction of ammonia, carbon dioxide, water, ammonia, carbon dioxide and water to give us ammonium hydrogen carbonate. For purposes of balancing, we only need a 2 here for ammonia as per the equation that I have written. Since this one is balancing ammonium carbonate, ammonium solid for 2. So we need a 2 here for purposes of balancing. So now this one is the first reaction that is being formed in step 1. For step 2, now the product that is being formed here, which is ammonium carbonate, the product formed is reacting with brine. The product formed is reacting with brine in a series of reaction as shown below. Now this is the reactant that we have, all the products that we have. Therefore, this product, as we have seen, is ammonium carbonate. The ammonium carbonate is reacted with brine, which is sodium chloride. And this is a kind of a precipitation reaction because we have 2 soluble salts. The salts are soluble, but they form a product whereby one of the product is soluble and the other one is insoluble. Now, since one of these products is insoluble, but now let us get to know the product itself. Now, the ions of ammonia attach themselves to those ones of chlorine. The ions of ammonia attach to those of chlorine, while the other one exchanges radicals, and this one is sodium and chlorine. Sodium and carbonate ions to form sodium carbonate, and this one is ammonium chloride. So what is the resultant? What are the products of this reaction? Remember, this one is the final reaction. Now the products will be ammonium chloride, and the other one will be sodium hydrogen carbonate. Remember, this one is 4. The other one will be sodium hydrogen carbonate. Since the 2 of them are in balance 1, then it is very correct to write it that way. Now, for purposes of balancing, we only need a 2 here. Now, the products which are being formed here are insoluble. One of them is soluble, while the other one is insoluble. And for us to separate the 2 of them in the separation tower, we only need to filter away the sodium carbonate, since this one is soluble. Yes, ammonium chloride is a soluble salt and dissolves. Now, since it dissolves, we get a precipitate of this one is a precipitate here, a precipitate of sodium and carbonate, which we need to expel it out. To do away with it, you only have to dry. Now the next process will be drying. Of the sodium and the carbonate. It undergoes the process of drying, then it is being filtered. You filter and dry. So the first thing is filtering and then drying. Then after drying, you heat it in a chamber known as the kiln at a temperature of of 300 degrees Celsius to decompose it to various parts. Now, even before we go to that point, we need to know the overall reaction. We have seen that the overall reaction for the whole process is very important to be noted. Now, how do you know the overall reaction? Remember, the product of ammonium carbonate is resulting from the reaction of these three. So for us to come up with the overall equation, we only need to write the three products, then add this one, and then get the two products. How do you go about it? We just add ammonia. It is a very long reaction. So we add ammonia plus carbon dioxide plus water, then plus this reaction or plus this reactant, so that we can come up with the two of them. Since this one is soluble and the other one is insoluble, then we're expecting to have to add ammonium, sodium chloride for us to get the two products of them. No, this one is the overall equation for the reaction. The overall equation for the reaction will be ammonia plus carbon dioxide, water, and sodium chloride for us to get the two products. We have seen the two products, one of them is soluble and the other one is insoluble. Now, which one is soluble? Sodium hydrogen carbonate is a soluble salt. So, from 2 that we learned about soluble and insoluble salts, where we say the soluble salts undergo complete ionization in a solvent. Now, this one does not undergo complete ionization, while this one undergoes. How does it undergo? It undergoes in this way, such that the ammonium chloride decomposes to its respective ions, whereby we have ammonium ions and chloride ions. And this is what we call the dissolving. And that's why they are soluble, because they can, in solvent, they decompose into their respective ions of the compound. We only have two compounds present here, the chloride ions, two ions present, they are ammonium ions and chloride ions. And now when they dissolve, they decompose into their respective ions. That's why they are very soluble. Now, the overall equation for the reaction will be a reaction of ammonia, carbon dioxide, water, and sodium chloride to yield ammonium chloride and sodium hydrogen carbonate. Now since we have come up with the overall equation, the next process will be filtering and heating of the insoluble one. And this one takes place in the kiln, whereby sodium hydrogen carbonate is being heated at a very high temperature of almost 300 degrees Celsius to form sodium carbonate plus and some water here. Remember, this is the next step that takes place in a chamber known as ignition chamber. So there is also some process. Now, this is one of the processes that yields composite. However, in the initial process, where you needed the raw materials, we have seen that carbon dioxide is one of them, ammonia, and also brine, which is conjugated sodium chloride. We also need some water. Now, how do you obtain the carbon dioxide used in this process? Now, carbon dioxide is obtained by two methods, and one of them is by heating of the limestone. Heating of limestone. Limestone is being roasted. You can use the word roasting instead of heating, because at very high temperatures in the ignition chamber, you can talk of roasting of limestone. Whereby we have limestone is calcium carbonate and undergoes heating to form two products, and one of them is calcium oxide and some carbon dioxide. Now, this is one of the processes. We have said there are two main processes in which carbon dioxide is being obtained. And one of them is the roasting of limestone, and the other one is the heating of coke. The coke is raw carbon, the heating of coke. Now, coke is simply carbon, whereby it is being heated in presence of oxygen to form carbon dioxide. Now, as you have seen, these are the two main processes in which carbon dioxide for the reaction is usually obtained. Now, the calcium oxide obtained here during the roasting of the limestone is being added, is usually added to water in the dissolving chamber. Remember, there is a chamber which is known as dissolving chamber, whereby the calcium oxide that you have here is being slaked. The meaning of the term slaking of lime, we have the slaking of lime. This means that we simply add water to calcium oxide. Now, slaking of lime means adding of water, as I'm just saying, adding of water. Now, the calcium oxide obtained here is being slaked. I've said that slaking is adding of water. How does this process take place? Now, slaking of lime is whereby we have the calcium oxide being added to water to form a solution of calcium hydroxide. This one is a soluble salt. Now, addition of calcium oxide. So in short, when water is added to calcium oxide, we get this product which is very soluble. And now this process is what we call slaking of lime. It is a very important process because the calcium carbonate or the limestone that is being heated it forms two products, and one of them is carbon dioxide, and this one is a raw material. Then the other product here, which is calcium oxide, is slaked by adding water. Now, after you get the product here, you get to the initial. Remember, you have said you have only four raw materials, and one of them is carbon dioxide. We have water, we have ammonia, and lastly we have what? We have brine, which is concentrated sodium chloride. Now, the product which I've gotten here, which is calcium hydroxide solution, is being added to the filtrate. Remember, in the overall process, or in the overall reaction, we say there are two products, and one of the products is ammonium chloride, which is very soluble. So this one is being filtered out. And number two, we have sodium hydrogen carbonate, and this one is very insoluble and it forms a white precipitate. Now, since this one forms a white precipitate because of its insolubility, now upon the slaking of the lime, the products of the slaked lime, slaked lime produces the product of calcium hydrogen or calcium hydroxide, which is soluble. Now, this product is being reacted with the soluble ammonium chloride so that we can try to see whether we can achieve the final process. Now, this is how it takes place. Calcium hydroxide is added to ammonium chloride, and the product for this reaction will be calcium chloride, where we have the calcium chloride and ammonia, which we have been looking for. This one is ammonia gas plus some water plus carbon dioxide. Now, this one is the overall process for the reaction. Now, the final process, because now we have heated ammonia, that's how we get our final product, which is ammonia gas. ammonium gas. Now, chloride is being used as a byproduct. So you are being asked to explain or to just take the byproduct of the process of the solving process, then the byproduct is simply calcium chloride, written as calcium chloride. We have gotten our ammonia. Now, water and carbon dioxide are being recycled back in the process because for us to get water again, then it is very expensive and also carbon dioxide. Therefore, it is important to note that water, since there are high temperatures in the kiln there are very high temperatures of almost 1000 degrees Celsius. Now, for the temperatures of 1000 degrees Celsius, water is being recycled to reduce or to minimize thermal effect because the temperatures are very high, then we need water to reduce the thermal effect. We also recycle carbon dioxide. Carbon dioxide also undergoes recycling because the production of it is very expensive. Remember that in the initial process we have said that carbon dioxide is obtained by heating by two processes. One of them is heating of limestone, and the other one will be roasting of coke. Roasting coke in the open air. Now, these two processes are very expensive, and for us to minimize the costs of the production of carbon dioxide, we need to recycle the produced carbon dioxide here, so that we do away with the thermal effect. So, to summarize the whole process, you only need to go through the main process that are being involved, as I've just explained above, so that we can go on to the final process of getting our ammonia gas. So you can simply summarize the process, and you have seen process number one is a reaction of ammonia. You can call it number one. This is a solving process. Step one, we have seen a reaction of ammonia plus carbon dioxide plus water to give us ammonium. This is ammonia, carbon dioxide, and water. Ammonium carbonate. This is our two. So we need our two. So this is the first process or the first step in step one. Step two, as we have said, you just react what you have gotten here with brine. So step two is a reaction of ammonium carbonate, which is ammonium. This is two ammonium carbonate reacting with brine, which you have said brine is sodium chloride, to get an exchange of radicals. So the exchange of radicals will be ammonia taking the radical of sodium, and the radical of sodium is chlorine. Therefore, ammonium takes chlorine, the exchange radicals. So this is ammonia chloride and sodium hydrogen carbonate. Remember, you have said that the products, one of the products is soluble and the other one is insoluble. And the soluble product here is ammonia, sodium carbonate, while the soluble one is ammonium chloride. This one is soluble. Now, due to its solubility, ammonium chloride is filtered out, while the sodium and carbonate is precipitated. As a result, separation takes place. Now, after the separation, we have said that step 3 takes place in the kiln, in a chamber known as the kiln, whereby we have very high temperatures of up to 3000 degrees Celsius, and the decomposition of sodium hydrogen carbonates takes place in that chamber, whereby upon decomposing, it forms solid sodium carbonate plus some water and carbon dioxide, which is very important in the whole reaction. Remember, we have said this one undergoes recycling for purposes of reducing cost. Now the other process will be noting down the overall. The overall equation for the reaction will be an equation 1. So you can say adding equation 1 to 2. You can call this one Roman 1 and you call this one Roman 2. Then step 3 will be adding equation 1 to equation 2. So when you add equation 1 to equation 2, what will you be having? So this is equation 1. Equation 1 will be ammonia plus water plus carbon dioxide plus equation 2, which equation 2 is dry, is the new product that is being produced there. So we expect to have the equation being ammonium chloride and sodium nitrogen carbonate. Now that is the overall equation for the whole reaction. Now the next step, which we can call step 4. Step 4 involves and the composition of this. Now about the composition, step 4 we have said initially that it is the production of carbon dioxide. And carbon dioxide we have said that is being produced using 2 steps. And one of the steps is roasting of limestone. And another one being the roasting of coke or heating of coke in presence of oxygen. Remember, we have said that coke is carbon. Limestone is being heated at a temperature of 1000 degrees Celsius, and limestone is calcium carbonate. When you heat it at a temperature of 1000, you get a product of calcium oxide and some carbon dioxide. Then the other one will be carbon reacting with oxygen to form carbon dioxide. Now we have seen that these are the 2 primary processes which lead to the formation of carbon dioxide, which is being used in the process. Now step 5, we have seen that the calcium oxide produced is being selected by adding some water. Therefore, we expect that step 5 will be calcium oxide being added to some water for us to get select lime, and we have said that select lime is simply calcium hydroxide. Now the calcium hydroxide, which is very soluble in water, the soluble calcium hydroxide formed is being added to the soluble product in the overall equation. In the overall equation, we have said we get one product which is soluble and the other which is very insoluble. Now the soluble products are being reacted to yield the last equation, and the last equation, you can write it on the top here. Then the last equation will be a reaction of the slaked lime with ammonium chloride, and see how it goes. So the slaked lime is calcium hydroxide with the ammonium chloride, which gives us what we call an exchange of radicals, whereby we get calcium chloride. This one is a byproduct, and our ammonia gas, which we have been looking for, and some water, which we are going to recycle, as well as carbon dioxide. Now, these ones are the, can call this one step 6. These are the 6 main steps that are involved in the solving process for us to get ammonia gas for use in industries. Therefore, a question we ask may be framed from any of these ones. So that when we ask, state the equation in whichever chamber that we have discussed. What are the overall equations? Why do we recycle this and why do we recycle this? So we have said, I will repeat this again, that water is being recycled to reduce thermal effect due to the iron reduced. So the thermal effect is reduced by recycling of water, whereas the cost is being catered for by the reduction or by recycling of the carbon dioxide in the process. We have come to the end of the process of the solving, whereby ammonia is being used, or ammonia is the gas which is being obtained in the overall process of the extraction of ammonia using all the steps. So it is very important for a student to be conversant with the main processes that are being involved during the process of which is known as the solving process for production of ammonia. We have come to the end of the lesson, unless there is any question. Since there is no question, have a nice day. We shall continue on the question next time.